In this section, we're going to be solving simple percent sentence equations, and then we'll move on to some applications. Now, there are two ways to approach these problems. One is to use proportions, and the other one is to write equations directly. And I'm going to show you both ways side by side. First off, what you need to learn if you're going to use this proportion approach is this percent number formula, which is percent number over 100 is equal to an is number divided by an of number. And if you have any trouble memorizing it, I like to say that is comes before alphabetically, and so that you can remember that is in the numerator, and percent means divide by 100, so that is understandable that that part is put over 100. Now I've got three equations listed on the board here, and notice in this percent number equation that 100 is always going to be in the bottom left, but something else is going to be in the other three corners. And what we have here in these three sentences I've put up here is a missing position in three different places. What percent? That is where we're missing the top left corner. What is? That's where we're missing the top right corner. Of what number? That's where we're missing the of number in the bottom right corner. Now let's take these three sentences and put them into this formula. In each case, I'm going to write something over 100 equals something over something. And so I'm just going to rewrite this 3 times because it is the same for all three problems. Now here we go. What percent? That is missing, so I'm going to put an X where the of number would go in the top left corner. Of 240, the of goes in the bottom right corner, so there we go, is 72. Is number goes in the top right corner. So there's a filled in proportion. Before we solve it, let's go on to the other two. What is? I'm missing the is number. 15%, the percent number goes over the 100. Of 90, 90 is the of number in that bottom right hand corner. 12 is, the is number goes in the top right. 30%, just write the 30 there, of what? Notice how in all three of these the X is in a different position. 100 is always reserved for the bottom left corner, but the X can be in any of these other corners. Now let's solve each of these. Sometimes you can do this in your head, sometimes you need to do a little bit of reducing and multiplying. Let's take a look at this first one. I like to reduce my fractions before I do cross multiplication. I notice that 72 and 240 are both even. So let's cut each in half to 36 and 120. And they're both even still. And I would actually divide by 4 now. Divided by 4 gives me 9 and 30. Okay, they're divisible by 3, so let's divide by 3 and get 3 and 10. Now what I have is X over 100 equals 3 over 10, which is a lot easier to solve. You can actually do this part in your head. You can look at the denominator and say, hey, I can multiply by 10 if I go to the left, multiply by 10 up in the numerator, and find out that X is going to be 30. And so our answer will be 30%. If you do not have the ability to do it in your head, you would cross multiply. One diagonal would give us 10x. The other diagonal would give us 300, and if we set those two cross products equal to each other, we'd have 10x equals 300, which would mean that x would be 30, and we'd have 30%. Let's look at this next problem. 15 and 100 can be reduced. They're both divisible by 5, so let's take these and divide by 5 over 5 and get 3 over 20, which doesn't reduce any further, and I don't see a nice neat way to go from 20 to 90. So this time I will have to cross multiply. The diagonal with the x in it gives me 20x when I multiply, and the other diagonal, 3 times 90, is 270. I would then divide each side by 20. 20 divided by 20 is just 1. I have 1x is equal to, and now over here I can divide. And I can actually cross off those zeros. That's essentially dividing by 10 over 10. And that leaves me with 27 over 2, which is 13 1/2. And I'm going to write that as 13.5. 13.5 is 15% of 90. Let's look at this next problem. I would reduce this fraction also by crossing off zeros. That's basically the same as dividing by 10 over 10, giving me 3 over 10. And then I can see very easily if I just multiply in the numerator, 3 times 4 is 12, and 10 times 4 is equal to 40, and my missing number is 40. We could have also cross-multiplied here. Now I'm going to take these three answers and write them off to the left here. The first one was 30%, the second one was 13.5, and the third one was 40. And I'm going to erase what work we've done here already. Now that I've erased them, let's go through and solve these using an algebraic approach. When we see what, we're going to replace it with of. When we see what, we're going to replace it with our variable x. Is going to turn into an equal sign, and of will turn into multiplication. So what percent? Okay, that's just going to be x of 240. Of turns into multiplication by 240. Is, which turns into my equal sign, 72. Something times 240 is 72. If I want that something by itself, I'm going to have to divide by 240 on the left side of the equation and on the right-hand side of the equation. Then I could do my division to get my answer, or I could simplify, and I'm going to divide each of these perhaps by 12. If I divide by 12, I get 6 and 20. And if I divide further, divided by 2 over 2, I can get 3 over 10. Well, 3/10 is a fraction, and it's not here looking like our 30%, but our answer needs to be a percent. Our percent number formula gave us straight 30% without having to do any conversions. This one here, we need to treat this as 0.3 and then move the decimal 2 places to the right to get this to the 30%. But we do get the same answer in a slightly different way. This next one, what is? That would be x equals 15%. We need to convert into decimal form. Move the decimal 2 places to the left, make that 0.15. Of turns into multiplication to make that of 90. We would then multiply and get 13.5. So when you're trying to find the is number, this method actually works pretty well. You go straight to it, but not when you're missing the percent number. Down on this next one, 12 is 30%. I'm going to write that as 0.30. Of what? That means multiplied by x. If I want x by itself and it's multiplied by 0.30, I'm going to have to divide each side by that 0.30. Now what I've got is, I'm going to move the x to the left-hand side, 12 divided by 0.3. When you do your long division, there's your 12, divide by 0.3. You can't do that, you need to divide by a whole number, so we move the decimal 1 place to the right here. That 12 was a whole number 12, now it becomes 120 when you move the decimal 1 place to the right. 3 goes into 120 40 times, and there's our answer. Notice how when we used equations we had 3 different approaches, but when we used this percent formula, the same problem was done the same way each time, and we didn't have to deal with converting our answer into a percent form. We didn't have to worry about percentages having to convert to decimals. So from here on out, I'm going to use this percent number formula when I'm solving these types of problems in order to maintain consistency.